Well, hey, everybody. Hey, if anybody is actually listening at the moment, please give me a mic check. I've had to do a little rework on my computer. It seems that my video card may have given up the ghost. I was talking to somebody, and all of a sudden it stopped working. So uh, I'm using the onboard video and change a few other things. Oops, hang on. Get the background. Okay. So, anyways, if you could give me an audio check, that'd be great. So, a couple of have asked for a little bit more advanced stuff. They think that I'm just kind of preaching to the choir for the people that already know Calc, which is pretty true. This is not to educate people that have never experienced any kind of math before. This is just kind of us kind of doing review and going over it, and then people want to listen in. That's fine, and if they want to participate, even better. But it's definitely not something in place of actually going to college or opening a math book by any such imagination. But since I was going to Khan Academy the other day, and there was a couple practice problems that Khan had for their implicit differentiation, I was like, well, heck, I might as well do a little presentation on it to see if we can get these implicit differentiation problems correct. This is something I haven't really gone over yet. So if you haven't seen what implicit differentiation is, it might be a little confusing, and I don't have anybody in here to as a sounding board to talk to. So it's just going to be me until somebody decides to join. The link is at the Great Debate community. You can join anytime. I've also put the link in the outside feed that we usually use for Hangouts. So anyway, we're going to jump into it. Let's see here. Let me go screen share. Yeah, I'm down to one monitor right now, so it makes it very, very difficult. Okay, because now I can't see the outside chat if you guys do anything, say anything. So I'll check back periodically. So here's the problem we're going to be working on. It wants you to find dy dx of x squared minus x squared y plus 3x cubed equals 4. And what they mean by implicit differentiation is in this form where you're not explicitly showing the formula in terms of y. If I have a formula such as like y equals x plus 3, that's explicit. That means I'm showing exactly what the formula is in relationship to y. Here it's not in terms of y. And it'd be very, very difficult to actually isolate y in order to get this into a form where you can explicitly show it in y. So what you have to do is you have to basically differentiate as it's written, which you can do. I liked this particular problem because it pretty much used every rule that we've gone over so far. And I did get it right. So this is the work that's involved. So let's look at this. Okay, here's the practice problem, and hopefully you guys can still see in the outside chat. I'm gonna pull up really big there. So let me just check that you guys can see this real quick in the outside feed. Eric, can you see it? Yeah, it looks pretty good. I can see that. All right, so this is. Oops. People messaging me. Oh, hang on. No. Okay. I'm not going to find a work yet. Okay, so this is how I started it off. And I've checked all this out, so I'm pretty sure it's right. So when we want to take the differentiation of both sides, we just d over dx of both sides. Okay, I think everybody even knows that part. But now we want to do a term by term. We literally want to differentiate each term, and each terms are separated by addition and subtraction, right? So the very first term, we're going to break this down and do each one of these terms here. The very first term is a composite function. So you have to apply the chain rule. We have gone over the chain rule a little bit, but we didn't really talk too much about it. But the chain rule is how you actually do a differentiation when you have a composite function. So I set up the chain rule like we've seen it before: dy over dx, dy over du, du over dx, and then let y equals u. So when you actually apply the chain rule, you'll have du over du, d over dx. So when you back substitute u in there, you actually just taking the differential of u, right? Or taking the derivative of u, where we know the derivative of a u squared is 2u, right? That much we already know. We can do the power rule for that. So what we're left with is du, d over dx y, which we can just change into another format using the prime notation, right? dy over dx. This whole thing, d over dx y, is exactly the same as dy over dx. So I could actually even write that if I wanted to as, and I'll just do it for the specific problem here. I can actually write that over dy over dx. Okay, so this all these three different ways of saying the exact same thing. This is why I want people to get kind of experience with the notation, because this right here, this d over dx y is exactly the same as dy over dx, or y prime of, okay, y prime is equal to this, which is equal to this. So I be rewriting it in this kind of notation because you'll see later on it's easier to work with the final equation that you put it in. Remember, this derivative is only the first term, right? So the derivative of y squared is not just 2y, it's 2y with respect to y, with respect to x. So you've got to include the dy dx in there as well. So it's going to be a chain rule. So it's going to give 2y y prime. Okay, that again, we haven't really gone over why that is, but we're taking it with respect to x. We're not doing a differential on the x variable. We're doing it on the y. So you're left with the 2y, but it's with respect to x. So we have actually going to be left over in the chain rule this y prime. Let me see if you guys are following along real quick. Okay, nobody's complaining so far. Okay. So the next term, right? The next term is this y squared, x squared y, right? Well, that's going to be the product rule because I have two variables and I'm timesing them together. I have x and y. So I just apply the prime rule, or the product rule, which remember is the derivative of the product of f of g is going to be equal to the derivative of x times g plus or times the function of f times the derivative of g. So I just did the step by step. So the derivative of dy to the x of x squared y is equal to 2xy. And then the derivative of this part right here, this f g of prime is equal to x squared dy dx. And then we are just going to re-annotate that as y prime. So the derivative of this whole thing in the middle right here, this x squared y. Now, by the way, if you notice, I didn't take the derivative with the minus sign. I just took the term itself. And the reason being is when you stick it back all in, that minus sign comes back into play. So you don't have to really worry about it. You're just taking the term. You're taking the derivative of x squared, excuse me, y squared. You're taking the derivative of x squared y, and then we'll go to the next one. So I'm not worried about taking the derivative with adding the minus sign. I find it to be easier. And as you guys know before, I told you whenever I used to do this stuff, minus signs killed me. So just forget the minus sign. I'm just taking this as the derivative, and that's what I'm getting. Now the third one in the third term is 3x cubed. Well, we have gone over the constant rule, and 3x cubed, we know we can pull that 3 out, right? So I can just pull the 3 across the dy dx, or excuse me, d over dx, and I'm left with x cubed. Well, I can take the derivative of x cubed just using the power rule, right? So I know if I drop down the exponent to the coefficient and drop 1 for the exponent, I get 3x cubed, or 3x squared. And then you can draw the constant out again, and 3 times 3 is 9. So 9x squared. So this term here, the 3x cubed, the derivative with respect to x is going to be 9x cubed. And then the last part of the equation, right, is this right here, d dx 4. Well, we know that derivative of any constant is 0, right? So now we just substitute back in. And this is kind of a thing about calculus. It's called, if I remember correctly, it's called the summation of sum of derivatives. I wish Leo was here. I think it's called the sum of derivatives. I haven't looked for a while. But basically what it is saying is that the derivative of this quantity is going to be equal to the derivative of each one of these added together. So the derivative of this is equal to the derivative of y squared minus x squared y plus 3x cubed. So it's going to be the derivative of all these things added together. Okay, and then you can just express it this way. So the derivative plus or minus f of g as a functions, the derivative will be plus and minus as well. So now we just add it all together. So we know the derivative of x squared is 2y dxy, which is the same thing as y prime. We know that this term here, the minus 2xy x squared dy, is just this right here, right? And then I also know that the third term, 3x cubed, is 9x squared derivative, and then obviously the derivative of constant 0. So this is the equation that you get when you put all the terms back together. Now, I think it's easier to write this in prime notation. Let me show you why. Because you'll see it many different ways, depending on what class you take. So you'll see it this way. You also see it this way, right? With the y just being up here, right? That's all it's basically doing is putting the y in the numerator. And again, don't think of this as a fraction. Sometimes you're able to, when you start working with a separation of the separation of, what's it called, the differentials, the dy and dx do split, and you can separate them kind of like a fraction, but it's probably not good in, again, the habit of thinking they're a fraction, because people go, oh, look, here's d over d. I just cancel that out. I'm left with y over x. No. So these are not to be thought of as a fraction, although sometimes you can separate the differential dx to dy, but we haven't got into separable equations yet. That's diffy q. We could do one of those later on. So this is what you actually end up with when you actually use the prime notation. So this thing here, the dy over dx, is y prime. Okay. This stays the same. This right here, this dy over dx, is again y prime, and then 9x is 0. So my actual equation that I came up with is this right here, and this is workable, because what I'm trying to do now is I know that y prime is equal to dy dx, right? And when it's asking you to find the implicit differentiation, it's actually asking you to find dy dx of this, is what it's asking you. So I know that I could actually try to isolate for y, or y prime, and get that on one side, and that way I can solve the actual equation, put it more of explicit form. So I can draw out a single y prime from this side of the equation, right? Move that over. I'm left with 2y minus x squared. Okay, so I have this quantity, and on this side, just the same. Now I can just do a simple division of this whole quantity, 2y minus x squared, and I'm left with minus x squared plus 2xy over 2x, which should be 2y minus x squared, in y prime notation. Now let's go to actually what Khan Academy has right here. So here's my choices. Boom, 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 boom. Well, the only one that looks pretty much exactly like what I came up with. Let's see here. Let's put these side by side. Make sure we get the right one. Okay, that's side by side is not going to work. That's the wrong one. Okay, so now remember, this could be expressed differently too. This could be 2xy minus xy squared too. I always put the exponents, the highest exponents, to the left hand side. I think this is good form. And this minus side could be dropped down too. It could be minus this quantity, or you can just stick it in the numerator or denominator. It makes no difference. It's all just a matter of format. So let's see here. Which one is this one? Okay, so it's this one here, A, right? Would you guys agree that 2xy minus x squared, which is the same thing as saying minus x squared plus 2xy? Same thing on the top. It's shown a little bit different because obviously it's moving this on this side, the minus x squared. So let's see what you guys think here. Stuart's like, I haven't had enough beer for this. You know what? Beer's good. Red Eye, what do you think? You think we're going to go with A here? Yeah, we're going to go with A. So let's see what we get here. And then we're going to go check. Yay! Great work. All right, so that first one's down. You've done your first implicit differentiation problem. Yay. Let's go to the next question. Oh, we got somebody in here. Wait, somebody popped in. We get the show. Wait.
I can't really talk, so I'll just listen.
Okay, let me give you mods here. Let me stop screen share just for a second so I give you mods.
Okay.
So if anybody else comes in. I forgot. I gotta make sure I'm right. Okay, that way you can show people. You missed the first part, but that's okay.
Yeah, sorry about that. Like I said, I can't really talk, so I'll just listen.
Okay. Well, we're gonna move on to the second one here. Screen share again. Hopefully my video card didn't go out completely. It's a really good video card, and I love having two monitors, even as a piece of shit second monitor. All right, so here's the second problem we got. It says x cubed plus 2y squared minus x squared equals 2. No, wait, that's not the problem that I had before. That's not the one I solved. Let's see here. Okay, that one's A. Page is out of date. Okay, let me refresh. If not, it's okay. We can go by the problems that I actually did. Did I do this one? I didn't stick in the point. I just did the differentiation. So 1 second here. That's okay. Okay, so I didn't do the point thing. It was a different question. So we're gonna skip that. We're just gonna actually do the problem itself. So here's what we want to find the dy dx of. Okay, so we're gonna do the same exact thing, and I didn't do each thing like the chain rule and product rule because I did in the first one and showed, okay, in the first term we have to use the chain rule, and the second one we have to use the product rule, and the third one we have to use the constant rule. Fourth term or whatever, we use the power rule or derivative of a constant. So I actually showed you each one, what each rule we're going to be using, right? So I did it from here on out. Hopefully we can kind of figure it out ourselves. So given this, we want to find the dy dx. So the d over dy for the quantity, we just set it up this way. We're just going to take the derivative of both sides. We automatically know that the derivative of a constant is 0, right? And then we take the derivative of each term because the derivative of a quantity is equal to the derivative of each term individually, plus or minus. So we just set it up like this. And we're going to take the derivative of each term. Now we have to go kind of term by term and get the derivatives. And these weren't that hard. That's why we were able to do it kind of quickly. Here, the derivative of 3y squared is basically, again, you just draw the exponent down times it by the coefficient, or draw the 3 across and do it that way. Here, I kind of drew the 3 across because we know a constant you can draw out, and I just kind of reset it up this way. And then I applied the product rule here because this is obviously y times x times y. So you have to take negative y times y plus negative x times derivative of y. Remember the product rule. And again, if you're not sure, I did post them up here, product rule. So we got to apply the product rule there. Oops. That's not number 3. So and then again, the derivative of constant 0. So we setting it up with the rules in the product rule here. The first derivative, right, after I take the 3 out, I'm just going to take the 2 down and times it by 3, I get 6. Right, I subtract from the exponent y, and it's with respect to x, so I've got to leave the y d over dx, dy over dx in there. Dy over dx is equal to y prime. So the derivative of y here with respect to x is 6y y prime. Here, I'm not dealing with any y's. It's with respect to x. So derivative of x squared, we know is 2x. Boom, done. The derivative of negative x with respect to y is, let's see, is negative 1 times y, which is just negative y, because the derivative of negative x is 1, right, times y. So this leaves me negative y, and then x minus derivative of y that's going to give me y prime here, because the derivative of y with respect to x, again, we haven't really gone into that, is going to be dy dx, or just y prime. So you have to just kind of go with this for a while, because again, we didn't really get into the discussions of how to do differentiations of other variables with respects to other variables. So, but when we end up with this form right here, we do the same thing. We try to isolate the y prime. So I'm going to draw out the y prime by moving this over to here, right? Minus 2x on this side of the equation. I'm going to move y over this side, so I change the sign, so I get negative 2x plus y. This leaves me just 2 terms, both with the y prime in here. Now I can draw out the y prime. I can factor it out, giving me 6y minus x. Then I can just divide each side by 6y minus x, and I'm left with the quantity 2x plus y over 6y minus x, or you can rewrite it as y minus 2x over 6y over x. So if you're following along the Khan Academy and you get that problem, this is the answer to it. Okay. Let's see where we're at in the live chat there real quick. Because again, my monitor situation sucks because I'm just talking to somebody and all of a sudden the video card went out for some reason, and I haven't been able to figure out why. So anyways, let's check here real quick. Red Eye, I will be lurking, still trying to make my computer table. Landon will be watching. Okay, that's fine. All right. So I think people are following along a little bit. So we're gonna get back into it. Again, I wish the damn problem was exactly what it was supposed to be, because you know what? Maybe I try a different browser. Maybe I can get it to reset that way, because Khan Academy doesn't reset very easily. So let me try something real quick, because I didn't do it in Firefox. I think it works on cookies or something. Let me just try something real quick. way we kind of follow along. Khan Academy practice. First one is A. Check. Yay! Okay, that worked actually. Good, good, good. All right, so let me screen share. Okay, so in Khan Academy, here again, this is the problem that we just. That's a different problem I was doing. Okay, so the problem we were asked to do is this right here, which is okay, this one right here, right? Right, we did the first one, so we know that one's A. We're gonna check that one. Should be right. Next question. Should be the next one. Yeah, see, it's not. I know it's 1/4, but that's not the. I don't want to find a specific one value at a point. I just want to get the derivative. All right, so we're just going to be doing the derivatives because I don't want to evaluate it at a point, but we're just going to be doing the derivatives for the next problem. And you can check it with Wolfram Alpha if you want. Let me close that out. All right, so the next problem. 2xy plus x cubed minus 3y squared equals 5. So, Min, I know you can't talk too loud, but how are we going to set this up? We're going to set it up like this, right? We're going to take the derivative of both sides. Would you agree?
Yes.
Okay. The derivative of a constant 0, right?
Yep.
Now we take a term-by-term thing. So the derivative of 2xy plus the derivative of x cubed minus the derivative of 3y squared. Okay. So the derivative. Well, here we're going to draw the 2 out, right?
Yes.
Because it's constant. So we just want to take the derivative of xy. We want to take the derivative of x cubed, which is just 3x squared. We know that one, right? And then I'm going to draw the constant out. So I'm still left with 2. I've still got to take the derivative with respect to x, but we're working with the y. So we're going to end up with a dy dx, which is the same thing as a y prime. So that's what you got to remember. If you're taking the derivative with respect to x for the x variable, you don't have that, but you do with respect to x if you're doing it of the y. So remember, the d over dx of dy of x times y is equal to y prime times y plus y times y prime. That's why you end up with this, right? Because if I take the derivative of this, what do I end up with? I end up with 1 times
plus xy squared at the prime.
Yeah, I end up I have the y prime in there that I still got to deal with. So
yeah,
when I'm taking the derivative here, the 2 dx dy, right? It's going to end up being 2 times the product rule, right? But the product rule of x times y equals this, y plus x times y, because I'm applying the product rule here, right?
Yeah, dealing with the product rule.
Right. Which it was kind of weird. I mean, what's the derivative of d over dx of xy with respect to x? Well, it's this right here, and I just showed people why, because the derivative of the product rule for xy is equal to this, and then you just end up with that.
Yeah.
Then on here, what happens? Then
you distribute the 2.
Okay.
Then the negative 6y derivative.
Right. Negative 6y prime.
Yeah. Prime. Sorry,
these are products. The other ones are going to be more applying chain rule and stuff and power rule. But when you see this right here, that's obviously a product. So you got to remember what rule to use. So here, yes, it's going to be 6y prime. So now we're going to distribute the 2, right? That's easy. Boom. And then, excuse me, we could just start moving it around to try to isolate y prime on one side. So if I want this term here, because it has a y prime, and I want this term that has a y prime, I got to get this over here and this over here. So I just subtract minus 3x on this side, and I subtract minus 2y from this side and move it over here. So I end up with minus 2y minus 3x. And again, you can have this the other way around, right? You can have it minus 3x minus 2y as well, correct? So I take the y's and I factor them out, and I'm left with this quantity here, 2x minus 6y. Because again, if I just distribute the y of distribution and multiplication over subtraction, I get this. So I can just divide this whole thing by this quantity, and I end up with.
And you get y prime equals negative 2y minus 3x squared over 2x minus 6y.
Correct. There you go. That is the solution for this particular equation. That's the derivative. Now again, this is a little bit more advanced than what we've gone into before. This is doing implicit differentiation. We're going to do one more. Again, if you go to Khan Academy and try to practice these are the correct answers. So when you go do it, at least you know these are the correct answers.
Yeah.
All right, so walk me through this one.
Okay, so as you said, you use dx on both sides,
Okay.
and if you go down, you distribute to everything.
Okay.
So here you would use 3x squared times y plus 1 times.
Well, remember,
prime?
remember on this one, this is a product rule again. You're going to end up, when you do the derivative, right? You're going to end up with 3x squared y prime.
Yeah, that's what I'm saying. That's
Over
what I was.
So you end up with two different things. Remember, you got to use the product rule. The product rule again is this right here, right? The y prime y plus y x prime. So we're going to end up with the derivative of whatever your function is times y plus the function times the derivative of y. Okay, so when you do that, you actually end up. You'd have to do this on paper because again, it's kind of hard to see right now.
Yeah.
But what I'm actually doing is I'm taking the derivative. I kind of showed it this way so you're seeing what's happening. I'm taking the derivative of this times y plus the function times the derivative of y.
Yes. So there will be 3x squared times the derivative of 3 cubed will be 3x x squared. X cubed would be 3x squared times y plus x squared times y prime.
Mm-hmm. Right. So that's the first term. Exactly correct. Exactly correct. And then the second term is really simpler. We don't have a y to deal with. So what's the derivative of 2x squared?
4x squared.
How do we get
just
that?
4x. Sorry, just 4x.
Yeah, just 4x. And how do we get that?
The power rule.
Power rule. Just drop this down here. We end up with 4x.
Yes.
X 2 minus 1 is 1. So x just x. So yeah, simple power rule. Here, again, this is not something we use the power rule for, but I think it's actually the chain rule for it.
4y cubed times y prime.
Right, because we end up again. If I would have shown you in a different presentation, you actually end up with 4y cubed, and then you just end up with a dy dx, and I'm just noting it as y prime. So right on the money, right on the money.
Yeah.
So now we just need to isolate.
Okay.
Oh, somehow got deleted here. Well, I guess we're gonna have to do it from scratch here. All right, well, let's continue on. I don't know what happened. So let's just work it out, I guess, guys. So y prime. We want to isolate the y primes on one side. So x cubed y prime plus 4y.
Steve, why x cubed? Like, look, you're. Are you?
I got it. Don't worry.
Okay.
And then on this side, we're going to be minusing 3x squared y plus, minus 4x.
Well, would it be plus 4x?
Yes, you're right. Signage, right? Yeah, because I'm subtracting 4x.
Yeah,
on this
and
side.
then if I can,
I'm adding 4x on this side, so I've got to add 4x on this side.
Yeah, and can I
I'll fix the y here in a second.
And then you factor out the y prime, and divide by, and then
let's factor out the y prime exactly. So let's factor that out right now. So plus 4y cubed. Yeah, that's nice. Hang on. Okay, so let's factor this
equals negative. Okay.
Equals right.
Negative x. Negative 3x cubed y plus 4x, then y prime equals negative 3x cubed y plus 4 over x cubed plus 4y cubed.
All right, this is, I'm gonna do it shorthand over. I'm just taking this whole quantity here. Can you see that? I'm just taking the whole quantity. I'm going that way. There you
Yeah.
go. So there you go. And that's exactly right. And you don't even have to show these parentheses, by the way. I like parentheses only because it shows you the quantities, right? It
Yeah.
shows you that I'm taking this whole quantity and I'm moving it under here. I think it visually shows it better, but you don't have to have the quantities. I mean, I could write a parenthetical group just like this, right? I could do it on the top if I want to. Those all being the same things, right?
Yeah.
I think when you use these grouping symbols, it really does kind of show you what's going on more. I can, if you didn't have these parentheticals, I mean, granted, it's a distribution function, but like right here, when it's already been distributed, it's a little bit harder to see what you're doing. Here, go boom. I just want this whole quantity. I want to divide it to get rid of it on this side. I want to divide it on this side. That's it. So it's a little bit easier to see, right?
Yeah. Now, Steve, would you also get a problem where you have to use the quotient rule, or does that not happen?
Yeah, I went over the quotient rule the other day, but I'm going to be doing it again.
I meant when it happens in the in implicit differentiation.
Implicit differentiation.
Like,
Yeah, I mean, if I have
the product rule.
if I have a function that has a quotient to it, then yeah, you'd have to apply the quotient rule.
Yeah, I was just wondering.
But I'll tell you, sometimes it's easier to rewrite a quotient in terms of a non-quotient, right? You could actually rearrange things, and sometimes you can get rid of the denominator in some cases.
Yeah.
So if you can do that to avoid using the quotient rule, I would do so. But
yeah, I just figured I'd ask, because I mean, it seems like, oh hey, Ronnie.
Yeah, that's just this icon. Okay, so we're at now. So
so are we done?
Says, if differential equations exist, why do we still see calculus roaming around? That's a good question. I don't know.
I know it seems like a parody of if monkeys. Yeah. Anyways,
let me see if I got any more problems. I had some other ones that I was working on. Let me see if I thought I had additional problems. If I can find two more that I was working on. Let's see here. More practice problems. Here we go. Okay, these are two more. These are actually pretty easy. So we're actually, these are really easy. Or the first one's really easy. So we're gonna have the live chat actually solve these, I think. So let me make sure I'm not showing the answers. Okay, now I can screen share. The live chat. Let's see if we can work through this, guys. Present, and you get and do it on paper here. So we want to find y prime, which is equal to dy dx for x cubed plus y cubed equals 4. Okay. So work it out on paper, and let's see if we can actually figure this out. The very first thing what we would want to do is basically set up the equation, right? D over dx with the left-hand side with d over dx for the right-hand side, right? Which is the same thing as you can do it this way too, by the way. If I put d over dx and I'm just saying I'm taking the derivative of this entire thing. Okay.
Yeah.
Does that work?
Hang on, Steve. Okay. Y prime equals.
Let's see what some of the answers that we might get in the live chat is.
X. Okay, I didn't get it. Hold on, let me.
So yeah, you can see they can see in the live chat. So find the derivative of the formula x cubed plus y cubed equals 4.
Okay, hold on. I can do this.
We'll see if people can figure it out.
Well, if they do, don't tell me.
We have 8 people watching and 8 thumbs down. So 8 people don't like implicit differentiation.
Steve, if they get it, don't tell me.
That's fine. No, it's kind of funny that 8 people don't like implicit differentiation. I know we all hate math, but why thumbs down a video if you're actually trying to learn something? That's kind of silly, but whatever.
Okay, come on, I can do this. Okay, so
Did anybody get the answer?
Squared. Let's see.
Stuart thumbs it up. Thank you, Stuart. You're awesome.
Squared.
Lamed's like Steve. It's the G-man crowd, but her not people listening. Yeah, you're probably right, Lamed. But what are you gonna do, right? They're like, oh, the GDC has no educational shit. It's like, whatever, man. I mean, by the way, I'm doing this for myself too. I'm relearning this stuff, and I just going over with as I relearn it. So, and I enjoy doing these presentations. But thank you, Lamed. I think you're right. Okay, did anybody get the answer yet?
Hang on.
This one's actually much easier than the ones we just did.
Wait, hold on. Would y prime equals 0?
Well, no. Well, let's walk through it. Okay, so we can set the equation like this, right? dx.
Yeah, that's what I did.
Okay, and then we're going to actually just set it up. So we're taking the derivative of both sides, right? The derivative of d over dx of a constant 0. So we automatically know this side's 0. Boom, easy, done. Here, we're taking the derivative of 3x to the cubed and y to the cubed.
Oh,
so
wait.
What's the derivative? What's the derivative of x cubed?
X 3x squared.
Okay, we can do that in our head. 3x squared using power rule. What's the derivative of y cubed with respect to x?
3y squared times y prime.
There you go. Exactly. So it's 3x squared plus 3y squared times y prime.
Then you do negative. Then you do you move the negative 3x squared to the other side.
Correct.
Then you divide by you have negative x squared over negative y squared.
Well, negative x squared over y squared.
Yeah. Okay. I did. I messed something up. That's on my bad on that one.
Yeah. Okay. So Immutable Destiny got it correct. He is right.
I hate him.
Well, he knows math. I mean, he's taking advanced calcs. I don't remember what his actual level is, but I know he's taking advanced calcs. So, yeah. So it's negative x squared over y squared. Not that difficult because obviously the threes cancel out here. You figured that out, right?
Yeah.
I didn't point that out, but obviously those cancel out.
I was just going fast, and I think I made a mistake.
Now, when you start doing a differential equation, you actually start working backwards. This y prime, you actually express it in dy dx, and then you have to actually separate your variables, your differentials, and then take the integral on both sides and add your constant, in. Which we can do a quick one if you want. It's been a long time, but we'll do a quick one after this.
Yeah.
Okay, so that's my equation. By the way, it's dy over dx equals negative this because actually I think it actually said find dy dx. Okay, so it's the same way, same thing. Okay, so moving on to the next one. Now this one's a little bit harder. I'm not going to lie. This one, I basically worked it all out and I checked it on a math program. It's the factoring sucks. The factoring sucks. Matter of fact, I'm really not even going to bother with this one because the factoring is so long. It's just pain in the ass. I'm not going to bother. So let's actually do a quick differential equation if you want to see what it's like.
Yeah.
So let me go up here, get some space here. Oops, where's my new line? Okay, I don't even know where my freaking cursor is on here. So we're just going down to the bottom, I guess. What the hell? Now you guys have to help me walk me through this one. I haven't done these in years, so Immutable Destiny, you're going to have to help me walk through this. Let me draw a line here.
Should I invite him on?
Yeah, you can invite him in, of course.
Okay. Tell him. Well, okay. Immutable, sign back on Discord. I'm sending you a link.
All right, so let's say I have a very simple differential equation. dy over dx equals negative y over, oh,
Like
actually,
that
negative
works.
x over y. Okay, this is about the simplest differential I could probably think of off the top of my head. Okay. So when you're doing it, and again, this is going way back. I haven't looked over differentials in a while, so this is just for shits and giggles. The way I remember doing a differential like this is that this is a first order equation, and you have to separate the variables. And you have it's called separation of variables. So what you would want to do is you want to actually cross multiply. You want to bring the y and the dy together, and you want to use to bring the x and the dx together. So the way you do that, you just cross multiply, and you end up with y dy equals dx minus x. Or actually, minus x dx. Okay.
Oh, so you times.
Just cross multiply.
Yeah, you cross multiply.
Okay, so I end up. And now this. Remember, I said before that you don't want to think of this as a fraction, but when you're doing differentials in this type of notation, these actually separate.
Yeah.
Okay. Now we want to actually take the integral both sides because we're doing the antiderivative. So I think it is int y dy equals int. I'm probably going to butcher this to no end, but whatever. Okay, so I end up with this. I end up with the antiderivative here and the antiderivative here. So
wait, hold on. What is the derivative, antiderivative of negative x squared? I mean, of negative x be negative x squared over 2.
Yeah, well, I haven't taken the derivative yet, the antiderivative, but let's see what it works out to be. The antiderivative of negative x should be negative 1/2 x squared, if I remember correctly. Is that right?
That's what I just said. Yes.
Oh, okay. Okay. So let's do that side of the equation first. So it should be, what'd you say? It's negative 1/2.
Well, I said negative x squared over 2, which negative 1/2 times is the same thing.
Yeah. Basically that.
Well, check Discord.
Right? Plus c. Plus a constant, right?
Right, plus c.
You got to have the constant of integration. Now, I used to do it this way. I used to do c1, and or it's actually be c2 and c1 on the other side. Now I'm trying to remember the derivative of y with respect to y. Is that just y prime plus c?
Are we talking about the other side?
Oh no, I'm sorry. It's y squared plus c. Yeah, there we go.
Okay, tell Immutable to check Discord. I don't know if you can hear me.
Immutable, check Discord. Yeah, okay. The antiderivative of just y is y squared. Isn't it?
Wait, hold on. Is it no,
over 2? See, 2
because
comes down.
Yeah, then you divide by 2. It's
1/2. It's 1/2. Yeah, it's 1/2. Yeah, it's 1 over 2. There we go. There we go.
Yeah. Okay. I only know this because I did some of them. I studied a little bit of integrals, not too much.
All right. There we go. Now that looks a little bit better.
Yes.
Because now and you can check these things in your head too, right? Since this is the antiderivative, which is the antifunction of the derivative, right? It's the integral. What's the derivative of this right here?
Hang on. Which one?
What's the derivative of 1/2 y squared? Well, it's just y, right? Because 2, because 2 comes over 2 is y. So you check your work. It's right. So same thing here. The 2 comes down is 2 over 2 equals 1. We have 1x minus 1x. And then the constants here, the constants of integration, well, the constants that come out of the integration, you can either write this way, or you can just put it as one big C if you want. Because it's what you actually end up with is C equals C 1 plus C 2. Actually, this is not capitalized. That's what you actually end up with. Or you can do a C sub T, right? That's your total, right? But it's basically, because they're constants, you can add constants together, right? I just deleted my thing. There we go. Go back. Okay, so that's how that works. And then basically, where do we go from here? We add the, let's see, we want to put the constants on one particular side, right?
Yes.
1/2 y squared. Let's do that first. We'll just rewrite it this way.
Wait, hold on. What does that say? C21. Maybe is it a typo?
No, just
Oh, I
17 and
see.
21.
You're. I really don't like how this program. I don't know.
Yeah, no, because when it types it out, it doesn't look right when you're typing it.
Yeah. You know what? I'm mutable. Never mind. Don't come on. I give you the link. You won't even come on. I mean.
Okay, so is that looking right there? Because I'm
Yes.
just putting C on one side. That's all I'm doing. And you can write it that way coming out of your integral too. You can when you're doing a differentiation or excuse me, a diffie q, you can write it this way. We were just taught to do it this way. So the concept was you understanding that each derivative is getting its own constant. That's the concept.
Why did okay? C equals C plus C1 plus. Oh, I see. You just put them together.
Yeah, I'm just saying that again. This is over. Okay, so now I have to times each side by. Now see, this isn't looking right. But it's got to be this way. So then you times each side by 2, right? To get rid of the 1/2. But it
Yeah.
has been on one side of this. So 2, so equals negative x squared plus c. Yeah, I guess that is looking right. Okay. So I just got, well, all I did was I times each side by 2. That gets rid of this fraction. That gets rid of this fraction. Agreed?
Yes. Okay. Now, how would you?
Now you just
Do
take the
you?
square root of both sides.
Oh, okay.
Square root of negative
So you're
x
left with negative x squared plus
plus
c,
c.
which I suppose it doesn't really matter because it's negative.
Is that the right answer, though?
I don't know. You're the expert.
Oh, I'm not an expert. I haven't done this in ages. I'm just a layperson. Listen, you know what? When you don't succeed, you check Wolfram Alpha, right?
Yep.
I haven't done a differential equation in ages. So let's check Wolfram. Dx or dy dx equals negative x y. Let's see what the answer is. Yeah, we're right. Negative x squared plus c.
Good job.
And what shit? Where'd we go here? We lost it. Here we go. Negative x.
So
Negative x squared plus
don't
c.
give. Yeah.
Yay!
You don't give yourself. You don't give yourself enough credit.
Dude, I haven't done this stuff in ages. Like I said, I'm just reviewing it myself. So the fact that I actually managed to get that right, I'm quite happy. Differential equations is a whole different ball game than what we've been doing. Because again, you're dealing with antiderivatives, right? And then once you start getting into antiderivatives, you start getting into what's called.
Well, I mean, I don't.
Well, you have indices, right? And these indices in the antiderivative, how far you want to take the area of their curve, and you could do indefinite or definite integrals. And indefinite would be obviously infinities that you're dealing with. So they can get complex really quickly.
Yeah. So can you explain? Okay, you stopped it.
Yeah, I just want to read the live chat real quick.
Yeah. Again, I invited Unmutable.
22 dislikes. Still see 8 people watching and 1 download. Every
Come on, guys.
That's pretty funny. Well, somebody's obviously on a sock and just. But see, this is the kind of trolling that we deal with, right? I mean,
Yeah, whatever.
Obviously these people that are downvoting, they're not learning anything, and that's fine.
Nope.
I hope the rest of the people in the live chat at least got something out of it, got some review out of it, because most people in the live chat right now have taken calculus.
Yeah. Well, I mean, I figured I'm learning something. It just sucks you had to do this late, but
yeah. No, it is one person. No, I know that, Lamed. Yeah, no, I know it's just one person on a stock account. I get that. It's okay though. Nobody really goes back and watches these videos. So matter of fact, it actually worked out great because it actually raises the ranking. Yeah. But if you guys want, leave comments on here after this video is done. So, it'll get far more views or far more likes than dislikes eventually. Most of them usually do, but it's okay. So anybody got any questions on implicit differentiation? I mean, we kind of went over it pretty quick, but you know, it kind of shows them actually how to do these problems, right?
Well,
I mean, there are ways of working these problems, and this is why we started with all these different rules, right? The product rule, the
I
chain
mean,
rule, and all this stuff.
Steve, not to sound arrogant, but it seemed a little like, I know it's probably hard, but it seemed a little easy if you know what you're doing.
Well, I
Like, I'm
mean,
not
to
trying
somebody
to
that
come
knows what they're
off.
doing, it probably is easy, right? Landon would
Yeah.
blow through this like crazy. Lamed probably, you know, understands this extremely well too. But for somebody who's never had math before, they're not going to understand it right off the bat. I get that.
Well,
Yeah,
I
I really
mean,
do.
yeah, you know, I've used Math is Fun. I don't know if you heard that site to learn
Of
some of the
course.
stuff.
Yeah, of
So,
course. Yeah. Yeah, there's a couple different sites I use. But I want people to understand the concepts, right? They understand the power rule, they understand the chain rule, they understand the
yeah.
quotient rule. But I think this was a little more advanced, obviously, than what we had been doing, which people have been asking for. They're like, why is Steve doing easy stuff? Well, you know, not everybody on the same level, right? So, you know, I wanted to do a mixture. I want some of these to be a little more advanced, like this one, and then I'll go back and do a very simple one. So, Stuart says, "No, good show. I like brushing up on this, Steve. Thank you, Stuart. And I'm glad that people actually do get something out of these things. I don't mind the haters. I don't. Um, you know, we see a lot of hate in the Great Debate community, a lot of drama. I'm just like, fuck it all. I don't care. The drama is drama. People love the drama. Anybody says they don't like drama is just outright lying, because you guys all love the drama. I mean, if it wasn't for the drama, you wouldn't have shows like Talking Shit Tuesday. So,
Yep.
yeah, I mean, the big thing was that, you know, I'm going to run my channel the way I want to run it. Nobody's going to tell me otherwise. It's my channel, not this one, right? I mean, this was my channel too, but I mean, my main channel. That's all that was. So if there's drama involved with that, you know, just blow it off, guys. We all know what we want the Great Debate community to be. We all know what we want to learn stuff, and we want it, you know, to be part of something. If people don't want to be on that ride, it's fine. It's up to them, right? And they wanted to sit there and stock accounts and thumbs down things. Yeah, so be it. What are you going to do, right? You know. So with that, guys, any last questions before I end this? And what we're going to do tomorrow, the next day?
What are you going to do tomorrow? Yeah, well, Matrices is definitely, yeah, I agree with that.
Matrix would be good. But there's something else I want to go over too, and I don't remember. Some basic stuff.
Well, hold on. You know, how about you go over vectors first?
God, I took vector analysis, but dude, I don't think I remember enough vector analysis to even really bother. I think before we do vectors, it might help if Jade had her presentation on complex numbers. And I was going to do one on sine and cosine, just for wave functions, because people had asked about that.
Well, I mean, I was still going to do I was actually going to make a video on the real number system, but every time I try to record, I stutter too much. I'm like, fuck it.
Well, we can kind of go over it. I mean, we can see what you got to kind of go over it. I mean, I was trying to explain, you know, something in the live feed earlier. Brian is out there. You know, Brian was trying to say that 0.99 repeating isn't rational. Well, of course it's rational. All repeating decimals are rational by definition. And
yeah.
when you start saying, well, it's not true, and when it's a definitional thing, then you kind of outside the realm of mathematics at that point.
Okay, I don't mean to put the authority card, but how can they hope to argue against 2,000 years plus of not scientific, of mathematical, you know what I mean?
Yeah, I don't know. I don't see I can argue math. I mean, this is 1.99 repeating is an absolute mathematical fact. Nobody in the world is ever going to be able to change that. It's just it's a way that our system's set up. It has to be that way. But I had that little debate on, or that discussion on it. Which
yeah, I know. I saw it today. Some of the stuff he said, I was like, what the fuck?
Yeah.
But I actually did 1 divided by 3 on the calculator. It's 0.3253, and then I did 0.3253 times 3, and it comes out to 1.
Well, don't. Okay, here's the problem. When you're using a regular calculator, though, calculators do round, and so you can't really take that as a proper way to do an infinite summation. But yeah, complex numbers, Eric, we do need to go over. I'll tell you what. I'll do a simple presentation on complex conjugates, and maybe
complex
touching in the
conjugate.
quadratics a little bit.
Hold on.
Maybe.
Correct me if I'm wrong, but wouldn't complex conjugates be with when you have hold on. I've actually did this a little bit before. Where say you have a plus bi over a minus bi. In order to get rid of that, you would do times. You would times by the conjugate of the denominator, the positive, the opposite of that. Is
Yeah,
that what?
the complex conjugate is really, if I just say like an a plus bi, right? The complex conjugate is a minus bi.
Yeah.
That's all that really is. And you use that in quantum and stuff. People are saying I should download this video, delete it, then re-upload it.
Why?
I don't know, because of the downvotes. Whatever. The downvotes don't mean anything.
Dude, who gives a shit?
Yeah. You know.
It's all about learning, man.
Yeah.
Learning.
But
We're all
I
connected.
appreciate the comments more than anything else that people do on the videos. So if you like this video, Lamed, and by the way, Lamed is somebody who I'm glad watches this kind of stuff. I want to give Lamed something of interest to watch because he is a supporter of my channel.
Is anybody ever tried sending these things to Ronnie? I mean, I'm curious to see if you block somebody if you send them videos.
No, those guys don't think we know anything, right? They don't think anybody in the GDC knows anything about anything but themselves, right? They have no idea what we do and do not know. I mean, obviously, I'm functionally capable of doing this high level mathematics, and this isn't even that high, but this is definitely more mathematics than what Clown Posse would ever be exposed to by far, right?
Yeah, definitely.
Yeah. All right, guys. So I'm gonna end this. So Stuart and Eric and Brian and Lamed, all you guys, thank you for watching. Hope you got some good review out of it. We'll probably do more practice problems. I think implicit differentiation is very good practice. So if I find more practice problems out there, I might do another hangout just like we did here, and we'll try to go through each problem and see if we can solve it using implicit differentiation, because that's a crux of calculus, right? I mean, calculus involves a lot of implicit differentiation. So please leave a comment in the video section that you like this, and you can just tell the people that the person who thumbs down to fuck off. It's not a big deal. It really isn't, but it's funny. I find it comical.
Yeah.
Okay, guys. Awesome.